Alright, hi Year 12s, this is Mr. Lim here again, and this is our first video on changes to volume in equilibrium systems. Let's get started. Okay, it's going to be a short video. We're just going to be identifying the types of the changes of volume that can affect an equilibrium system, because not all changes in volume do, and then identify the changes in pressure that don't affect an equilibrium system. Alright, so types of changes. So in a gaseous or aqueous system, alright, so you have to have some like either one of those two. In a gaseous system, you can change the volume of the container by either making it bigger or smaller by squeezing it or expanding it, right? Which leads to both a concentration and a pressure change. Now, generally we talk about concentration, but there was talk about pressure changes at the last exam, so maybe we should just remember that the pressure can also be used as a measure of how much stuff there is there. All right, but generally, in a gaseous system, you change the volume of the container, you change the concentration. And if we think back all the way to year 11 days, if you increase the volume, it leads to a decrease in concentration, right? Because the bigger something is, there's more space and the concentration decreases, and vice versa, right? However, in an aqueous system, you can pretty much only add. So if that's a gaseous system, in an aqueous system, you can only add water, which effectively means you can only increase the volume, not decrease the volume. Now, you can technically decrease the volume via evaporation, but it's too slow, and it doesn't really do the things that you want it to do. It's not as if you can just remove solvent from a thing instantaneously, but you can just add water instantaneously, right? So therefore, when you add water to an aqueous system, you increase the volume of the substance, and therefore you decrease the concentration. All right, so those are the things that you can do to make a change in the equilibrium system. Right. When you see that one of those two things have been done, you added some water or that you've changed the volume, the first thing you need to do is you need to look at the number of gaseous or aqueous particles on either side of the reaction, right? And then you need to count how many there are. Okay, so you need to determine the number of gaseous or aqueous particles on total on both sides of the equation. Okay, so what does that mean? Is if I have a reaction that's like 3A gas plus 2B solid goes to 1C, well, it wouldn't be really a 1, would it? C gas and 3D gas, right? And then there was that's an equilibrium system, and then there was some sort of change in the volume, right? You would need to count how many particles there are. So you've got 3 here and 2 here. However, remember, see, look, there's a trick. Make sure you don't count the solid or the liquid particles, and that's a solid, so therefore I'm not going to count it. Okay, oops, yeah, not going to count these ones. So now I only have 3 on this side, and I have 1 effectively and 3 here. So therefore that means I have 4 on that side. So just knowing how many gaseous or aqueous particles there are total on either side of a balanced equation. All right, so let's have a look then. That's the first thing you need to do and then you need to do all this other stuff later on, but we'll go through that in the next video. One thing to note is that if you add an inert gas, and what does an inert gas mean? An inert gas means that a gas that does not react with substances to the system. You can increase the pressure, but you don't actually change the concentration of anything. So therefore, it doesn't actually change the system. So these can be things like noble gases. But the idea is that this is to trick people who just use Le Chatelier's principle. The idea is that when you increase the pressure, you might think using Le Chatelier's principle is that, oh, the system will try and decrease the pressure. But no, because you've added an inert gas that doesn't do anything, it's not going to affect the concentration of the particles. And so therefore, you're not going to change the equilibrium. Okay, so it doesn't affect the equilibrium. So just when you see somebody add a noble gas or a gas that they say is inert, just remember that that is a no change to the equilibrium. All right, and that's it. We'll get started onto the cool stuff in the next video. Adios.